Welcome all. Today in building services, we will get to know about what is the main board and the distribution board and also about the transformer. First, what is the main board or the main switch? So, main switch is found adjacent to the energy meter, which has the complete electrical control of the buildings. So, this is usually called as the ironclad switch, and it will be available in the following types, that is double pole ironclad switch, mainly used for the single phase connection, and triple pole ironclad switch used for the three phase power lines with the three wire system, and triple pole ironclad switch with the neutral link, which is used for the three phase power with the four wire systems, that is three conductors and one neutral. Next is about the distribution board, which is used to distribute the electrical supply to the required number of subcircuits. That is, the number of points connected to one subcircuit should not exceed 10, and also the in terms of volt, the load, it should not exceed 800 volts. So each subcircuit must be provided with the suitable fuses provided on the phase wire, and the neutral is connected through a copper link. The phase and the neutral of each subcircuit should be independent of each other subcircuits. So in case of multi-story buildings, so each floor is provided with the different distribution boards, and all the distribution boards are controlled by the separate standalone distribution board, which will feed each floor separately. So this is an example of the distribution system of a single phase supply, which consists of the energy meter. So near adjacent to the energy meter, there is a main board or the main switch, which consists of the main switch and the fuse plug, and from there it is connected to the distribution board, which has the n number of subcircuits. So from that subcircuits, it will be transmitted to the other from the distribution board, it will be transferred to the other subcircuits, that is for example to fan or the to power circuits, so for lighting, for other purposes. Next is about the transformer. Transformer is nothing but a static device. So that is, it transfers the electrical energy from one part of the electrical or electronic circuit to other part of the circuit without even changing the frequency. So this transformer basically works on the Michael Faraday's law of electromagnetic mutual induction. So here is an example which represents, that is a blue color represents the transmission, then the transmission of the power, and the green color represents the distribution, and black color represents the generation power generation points, and also red color represents the transformers. So that mm, uh, red circle represents the components which act as the transformers to transmit the energy. Next is about the working principle of the transformer. The transformer usually works on the principle of the electromagnetic mutual induction. So that is, when the current is provided to the primary winding, it will start to behave as an electromagnet. Due to this, the electromotive force will be induced in the secondary windings as it comes in the area having the magnetic field lines due to the primary windings. So that is Vs, it can be measured as Vs is equal to Ns into d pi divided by dt. So Vs represents the secondary winding voltage, and Ns represents the secondary winding number of turns in it, secondary winding turns. Next is about the construction of the transformer. It mainly consists of these components, that is a laminated core, winding, tank, isolation, and the breather. So the laminated core, that is core are designed not to have current in it, but still if there is any leakage current or the eddy current, so in order to minimize this, the core part will be laminated. So that is for the laminated core. Next is about the windings, that is made up of the copper or aluminum coated, which will be of very thin layer of insulation. Next, the tank. The main function of the conservator tank of the transformer is to provide the adequate space for the expansion of the oil inside the transformer. It will be usually in the cylindrical or the cubical shape. Isolation, that is isolation will be done or provided by using the synthetic oil between a core and the tank. Then in terms of breather, when the temperature changes occurs in the transformer, insulating oil, the oil expands or contracts and there an exchange of air also occur when the transformer is fully loaded. So when transformer gets cool, the oil level goes down and air gets absorbed within. So these are the main components of every transformer. Next is about the types of transformer. Transformers are basically classified into three types on the basis of construction and the basis of windings, and third one is on the basis of coolant materials. What type of coolant materials that we use in a transformer. So on the basis of construction, it is again classified into three types, that is core type transformer, shell type transformer and the spiral core transformer. And based upon windings, it is classified as step-up transformer, step-down transformer and isolation transformer. And based on the coolant materials used, oil-filled self-cooling and oil-filled water cooling and the air blast. So these are the types of transformers. So one by one we will get into the types. So first is about on the basis of construction, that is core type transformer, shell type transformer and spiral core transformer. Core type transformer is nothing but it will be having core has the two limbs, so in which the coil will be winded in two of the limbs. So that is the core type transformer. In shell type transformer, it has three limbs which forms the two windows. So both the windings are wound on the windings will be done only on the central limb, that is the middle one. So this is a shell type transformer. And the spiral core transformer, the core constructed will be similar to that of the wheels of these spokes. So the windings are wound these spokes like a structure. So this is of the basis of construction. According to basis of windings, step up transformer, step down transformer and isolation transformer, nothing but here represent NP represents the number of windings in the primary side and NS represents the number of windings in the secondary side. When the number of windings in the primary side is less than the number of windings in the secondary side, that type is known as the step up transformer. When number of windings in the primary side is greater than the number of windings in the secondary side, it is classified as the step down transformer. When number of windings in the primary side and number of windings in the secondary side are equal, it is known as the isolation transformer. This is of the basis of windings. Next is about the basis of the coolant materials used in it. So first is oil filled self cooling and oil filled water cooling. And the third one is the air blast. So oil filled self cooling, that is oil filled self cooled type uses very small and the medium sized distribution transformers. So the assembled windings and the core of such transformers are mounted in a welded oil tight steel tanks provided with a steel cover. So the oil helps in transferring the heat from the core and winding to the case from where it is radiated out to the surroundings. So this is a oil filled self cooling transformer. Next, oil-filled water-cooled transformer. This type is used for much more economic constructions of the very large transformers. The cooling coil is mounted near the surface of the oil, through which the cold water keeps circulating. So this water carries the heat from the device. So this is the oil-filled water cooling transformer. Next is about the air blast. So this type is used for transformer that uses a voltage which is below 25,000 volts. So the transformer will be used at the mainly at the houses. So this is based upon the coolant materials used. Next, about the losses which will occur in the transformer. First loss is the copper loss, and the other one is the iron loss or the core loss, then hysteresis loss and the eddy current loss. Copper loss is nothing but it is due to the resistance of the primary and the secondary windings. That is, it is based upon the windings and the current flowing in through the coils. So this will be of the variable loss. Next is about the iron loss or the core loss. It is nothing but the magnetic loss which induce the eddy current loss and the hysteresis loss. So the core flux in the transformer is always constant for all loads. So the iron loss is particularly constant for all loads. Then for the hysteresis loss, it occurs during the magnetization and the demagnetization, that is due to hysteresis effect. Some energy loss in the core which will be called as the hysteresis loss. Next is about the eddy current loss, that is the leakage. Magnetic flux will generate the electromotive force in the core, produces the current which is called as the eddy current loss. Next is about the applications of the transformers. So there is main application is to transmitting the electrical energy over long distance through the wires. Then transformers with the several secondaries are used in televisions and radio receivers where several different voltages are required, and it is also used as the voltage regulators at almost in every day-to-day life. Thank you.